Hi everyone and welcome to the internet. So what we're going to be doing in today's lesson is having a look at the different types of chemical equation that we can write. So hopefully by the end of this lesson you're going to be able to write word and symbol equations, you'll be able to balance them and know what state symbols are. To start us off though, we've got 3 questions based around our previous lesson, so have a go at answering those in your books for me. Let's mark those answers then. So fluoride ions have the symbol of capital F with a little minus in the top right. Cesium ions are capital C, lowercase s with a plus in the top right. Strontium ions are capital S, lowercase r and 2 plus as the charge there. For question 2, the formula for hydrogen fluoride is HF, both capitals. Cesium bromide is capital C, lowercase s, capital B, lowercase r. And strontium oxide is capital S, lowercase r, capital O. Question 3, we had to write the formula for ammonium hydroxide, which would be NH4OH. Ammonium nitrate, which is NH4NO3. And iron 3 sulfate, which is Fe2, SO4 in brackets with a little 3. So obviously make sure that those numbers are in the right places. So the charges always in the top right, and the numbers of the individual atoms bottom right. So add it up for me, then you've got a score out of 9 for those. One other thing to make sure of is the capital letters and lowercase letters are in the right place. The first thing I want to look at today then are these things called state symbols. Now, this is something that we frequently see in chemical equations, but we don't necessarily understand at this point. What we actually have with a state symbol is an additional piece of information that we're being given by a chemical equation. And what they do is they tell us the physical state of those substances in that chemical reaction. And there are 4 of them that you need to know. If we've got a lowercase s in brackets, we have a solid. If it's a lowercase l in brackets, it's a liquid. Lowercase g is a gas, and then the AQ in brackets tells us it's an aqueous solution. So that just means it's dissolved within a solution. So I've given you an example of an equation that we would see at the bottom there. So we've got sodium, which is a solid, hence the S in brackets, and we're going to react that with water, which is a liquid. It's going to form sodium hydroxide, which is an aqueous solution, hence the AQ, and a gas, which will be hydrogen, hence the G. So write down those 4 state symbols and their meanings, and make sure you do learn them, because that could be a nice easy mark on your exam paper. I'll leave this up for a couple more minutes so you can write those points down. The first type of equation that we could see is a word equation. Now, when it comes to a word equation, what we're actually using is the proper names written in full for any of the reactants and any of the products. So what we'd have is something like the one I've given you at the top there. Magnesium plus oxygen makes magnesium oxide. So anything that is a reactant, then we put a plus separating them because they're obviously reacting together. And then between the reactants on the left and the products on the right, we put a little arrow just to show this is what we're making. So write down the top box and then have a go at writing the word equation for the reaction I've given you in the second box. So in this case, we start with copper carbonate, so that goes on the left, and it's not actually reacting with anything, it's decomposing, so it's going to break down. So we've just got that on the left, we put our arrow in, and then we're going to form copper oxide plus carbon dioxide. If you've not written carbon dioxide as the full two words, and you've got lazy and wrote CO2, you would get this wrong. Because if you're asked to write a word equation, we've got to use the full words. So give yourself a tick if you got that right. The second kind of equation we have are balanced symbol equations. Now these ones actually give us a bit more information at a glance than our word equations, because these show us the chemical formulas. So what we can see by looking at a chemical formula is what elements it's made out of, how many atoms of each element there are, and we also know the relative amounts of each substance involved once it's balanced. So write down that first sentence for me, then we'll have a little look to see how we actually go about this. So what we're going to do is we're going to have a look to see how we would write the balanced symbol equation for the reaction at the top. Calcium carbonate plus hydrochloric acid makes calcium chloride plus water plus carbon dioxide. So the first thing we need to do is we need to change the words to symbols. Now if they were giving you this as an exam question, anything that they don't expect you to know, so some of the less familiar chemicals, then they would write in the question calcium carbonate, CaCO3, and then they would tell you what it is. But for things like carbon dioxide and water, you're going to be expected to know those off by heart. They're not going to give those to you in the question. So the first thing we do is we look at the chemical names and we change them for their formulas. So calcium carbonate is CaCO3 plus hydrochloric acid, HCl, makes, our little arrow there, calcium chloride, CaCl2, plus water, which is H2O, plus carbon dioxide, which is CO2. So that's the first stage. Write that down for me in your books, and then we'll move on to stage 2. The second stage, we need to work out the number of each element on each side. So what I've done is I've divided our equation into two at the arrow. So just put that dividing line down the middle there. Then I've just made a list of the different elements. And remember, we can spot the different elements by looking for a capital letter. So we've got Ca is calcium, we've got C, carbon, O, oxygen, H, hydrogen, and Cl, chlorine. So we've got 5 different elements. So we write those down in the same order on each side of the line. Then we count them. So if we have a look at our equation, we've got CaCO3. Now, because there's no number after the Ca, there's just one of them. So we write 1. Look at the carbon next, the C. There's no number after that, so there's just one of those. And if we look at the oxygen, there's 3 of them, because there's a little 3 in the bottom right. So we need to write a 3 next to our oxygen. Then, if we look at hydrogen, no number, so there's 1. And chlorine, no number, there's one of those. That gives us the number of each element on the left-hand side. We then do the same thing on the right-hand side. No number after the Ca, so there's 1. If we go to the Cl next, then we can see there's a little 2 after it. So at the bottom we write a 2 next to our chlorine. The next element is hydrogen, and there's 2 of those because there's a little 2 in the bottom right there. So put 2 next to our hydrogen. Oxygen actually occurs in 2 places if we look. So we've got 1 oxygen in water and 2 oxygens in carbon dioxide. So 1 plus 2 gives us 3. And then our carbon, finally, just the 1 of those. So what we now have is a list of how many of each element we've got on the left and on the right. And from that, all we need to do is glance down and see if all those numbers match. If they do, it's already balanced. Your job is done. That is finished. In this case, they don't. Calcium's fine, carbon's fine, oxygen's fine, but hydrogen and chlorine, they don't match. So write that down for me. I'll leave it up for another minute. Then we'll look at stage 3. Stage 3 is where we're going to add a number to the place in front of one of those molecules to balance it. So what we can see from our little list at the bottom is we've got 2 hydrogens and 2 chlorines on the right, but only 1 hydrogen and 1 chlorine on the left. So we need another hydrogen and chlorine on the left hand side. And conveniently, in this one, we've got a chemical there that has both hydrogen and chlorine in it. So what we're going to do is place a number in one of those red lines. And the key thing to remember when we're balancing is the only place you can put a number is on one of the red lines in front of a chemical. And it will multiply that entire formula by that number. You can't stick it at the end, okay? You can't just make it HCl2 because you've changed the way a chemical is actually joined, and we can't do that. So we can only put numbers on the red lines in front. And the only place we need to write a number is in front of our HCl, and because we've got 2 on the right but 1 on the left, if we put a 2 in front of that, it means we then have 2 hydrogens and 2 chlorines on the left as well. The best thing to do with balancing equations is practice, practice, and practice. They're not going to give you anything overly complicated in the exam to do. Most of them will involve 2s or 3s in front of the chemicals. And what I've got here for you are 6 different chemical formulas that I would like you to write the balanced symbol equations for. So have a go at balancing these. Now, me standing here and reading out all the formulas to you is actually not very helpful. So what I'm going to do is I'm just going to give you a chance to have a look at the answers on the screen, and so you can mark your own work. So all the answers are on the screen there. Obviously, if you've got it right, give yourself a tick and give yourself a total out of 6. So I'll leave this up for about another minute and a half so you've got a chance to mark your work. Last thing to do today then are the plenary questions. So 3 for you all to have a go at today. I'll leave them up for about 3 minutes, but as always, if you need any longer, hit pause on the video and take as long as you need to answer them properly.